All right. Hi guys. It's fun to be back here. I'm doing a little demo here of PetSynth. Nothing too exciting, but I hope you enjoy it. I'll give you a little bit of a background on the project. I make old computers and video games and put them into service making music, essentially. And so when I came to the Commodore PET, I really couldn't find any music software, and so that's originally how I started developing it. And I developed it with the CC65 cross compiler, so I programmed it in C on the computer, and then I compile it and put it on the PET. So originally, I made a lot of effects, but I ran into some limitations when I would try to do a certain effect, and so I've been expanding and rewriting the program to accommodate these effects. And so today I'm going to announce some brand new stuff I've been working on that I haven't shared with anybody, so I'm really excited, and I hope you are too. So, the number one thing is I've developed a MIDI adapter for the Commodore PET. Now, at the end of my talk, I'm going to take it out and show it to you guys if there's time. I don't want to get into the next presentation. But I'll give you some of the background of the philosophy of why I'm building it the way that I've built it and the direction I want to go in. So first of all, I wanted to create a mono-synth product. I wanted to create something that I can play on a keyboard, but that is a very playable thing. So that's very different from someone who programs chip tunes or does tracker music. And so I wanted something that you could really do in a live situation or that you could just do on a keyboard. And so the mono-synth approach is based on the idea that you can only play one note at a time, and if you have additional voices on the computer or on the synthesizer, those voices change the sound or add to the sound. And so instead of playing all the notes at once and getting 4, 10, or 8 notes, or 12 as the theoretical maximum, you only get one sound, and it leads to certain kinds of performances, and I'll show you what that means later. So this is in alignment with the way old synthesizers were produced. And originally, synthesizers had a voltage-controlled keyboard which would send a single voltage out for whatever note was being held down at that moment. And so what I've done is I've created a MIDI interface for the Commodore PET based on a mono-synth approach. And so the reason I've done this is, yes, it's for the PET, but I want to port this to video game systems. And I want to do so in a way that will not require any additional hardware in the cartridge or to be modified in the video game system. Specifically, the original Nintendo is my big target for the software eventually. And so in order to do that, I need to send the note that is currently being played in one direction. And normally with a MIDI interface, there's a back and forth. Hey, I need some information. It sends a byte. Okay, I'm ready for the next. Okay, send a byte, and there's a back and forth between the computer and the MIDI controller so that it can ingest the notes as quickly as possible, but it is doing it and MIDI data is about 3 bytes at a time, and so it's taking those chunks, and you need that communication because there needs to be a synchronization between the MIDI controller and the computer. My mono-synth approach allows me to throw that out the window, and the benefit primarily is it's very easy now for me to program my software, and it's also very easy to port it to something like the Nintendo. And so for reference here, the Nintendo controller has a shift register that takes basically 4 switches that are the 4 buttons on the original controller. And so my adapter is going to work as if you were holding down buttons on the controller, but to send the currently held down MIDI note. And the benefit is you can plug it into the front of your Nintendo, and you can put a regular old cartridge in with a ROM on it, and you're rocking and rolling. So that's the approach I took, and at the end of this demonstration, like I said, I'll pull it out and I'll let you guys kind of see what I've done. Another goal I wanted was, it's open source, and so I wanted something that people could go to a website, literally copy and paste code into their Arduino platform, and press upload and have the MIDI adapter. I didn't want there to even be extra files with this thing so that people have to figure out how to copy things into the right direction. I wanted this to be easy for anyone to run with. And so what I've done is I've got, it might be hard to see, but there's 8 LEDs here, and those represent the 8 wires that I'm sending from the Arduino to the user port of the Commodore PET. 7 of those are for the currently held down MIDI note, and there's a maximum 127 notes that can be held down. And the last one is an effects bit. And so while I'm playing, you'll actually be able to see the lights that will show in binary the note that I'm holding down on the keyboard. So I've done that as a bit of a demonstration and originally as a debugging, but it looks kind of cool. So I'm going to stop talking and walk you through some of this stuff. Now, this is a very alpha version of the software, so I haven't implemented all the effects. In recent years, I've done demos where I've shown off all these interesting effects. I really only have 2. The one that's fun, which is a vibrato, and then the other one is a portamento, which is an effect I hadn't had before, and it was one of the reasons that motivated me to rewrite the software, because I wanted to do it properly. I've noticed a lot of the portamento effect, which is a sliding from note to note, is very slow in certain keyboards or certain implementations, and really good electronic music sometimes has a really fast one, and so I wanted to be able to do that. So I'll show you that as part of this demo. So here we go. So I've got my MIDI controller here. It goes into the Arduino. You're going to see the note that I've held down here. And so here we go. So there we go. Now I can change the octave of this keyboard. So I can go higher. I've actually hand-tuned a new table of tunings, both by ear and with a meter, because I wanted to get the tuning just right. And unfortunately the PET, the built-in sound for the PET is only 8 bits, and you can't really get good tuning with only 8 bits. There just isn't enough information to accurately tune a whole lot of notes. But it sounds a lot better than the old version. And that's about as high as you can go in a meaningful way. So there it is. So you can probably see the lights here as I play. It's pretty fun to watch. So now, because I'm doing all the MIDI on the Arduino, you may be thinking, well, that means you can't really do a whole lot of things with controllers or pitch bend or modulation. And you would be right, but I have done a couple of things. The first thing is I'm sending the modulation bit, which is this controller here, as this last bit here on the user port. So that allows me to do interesting things, so I can, in real time, turn off, in this case, the vibrato, but eventually I'd like to put it on any effect of your choosing. So. Anyways, that's a lot of fun. The other thing is I also have support for the pedal. So you can use your sustain pedal. Which is also nice. Again, that's on the Arduino. And the other thing is, just so you know, you might be thinking, well, okay, if you have more than one note held down at a time, well, what happens? And I've noticed that on some monosynths, I really don't like the way that it handles that. So what I would like to be able to do is, do some kind of cool, like, and have it automatically roll over to the last note that I've pressed down. So if you watch here, what happens is I'm going to press this note, and then this note, and then this note. Now if I let go of this note, it goes back to the second note I played and the first. So again, 1, 2, 3, 4. So it's basically maintaining a table of all the notes that have been pressed and the last time they've been pressed, and is automatically going back to the last note so that it's an intuitive experience when you play. Because otherwise, you might have something weird where you hold down a note and you play another note and you let go and it goes to some other weird note you weren't expecting, or who knows what. So I've seen some bad implementation, so I really tried to get this right, and I think I'm 99.9% of the way there. Another thing is I do have pitch bend. You might be thinking, well, how can you do pitch bend with MIDI if you're just sending the note over? I mean, you're not sending any more data. How do you do that? Well, I like an octave pitch bend, so really I'm just changing the notes, and that means that I can only really change one semitone, which is the difference between this and this. But because I like a nice octave in my pitch bend. I programmed it to do that, so I can, you know. So that's a lot of fun. And the other thing that I've done is when I send controller messages, I also have that change the note as well, different from the pitch bend. I noticed that Leaf's cartridge did that, and I thought that was really cool. You showed me that on your Vic cartridge, and I really like that. So you can use any of these controller knobs to act as if I've pressed a note, but because I can span the entire scale of 127 notes, you can do some interesting sort of effects. So I'm just going to show you right now. So if you do it really fast, you can do some neat stuff. And because I have it set to all of them, I can actually do some weird stuff. So if I start at the bottom and the top, if I go together, it sounds really cool. So that's a lot of fun. It's a lot of fun. So that is the MIDI interface, and that is the software. I mentioned the portamento because I showed you the vibrato. So, that's a little bug. It's a little bit out of tune when you stop the vibrato, but I'll fix that. And so the portamento, I'm going to activate that now. And just so you know, the keyboard still works. You can still play on the pet, of course, which is a lot of fun. But I'm going to turn on the portamento, and I'm going to show you some of that. So. That's a lot of fun. Oh yeah, one more thing. Unfortunately, the PET, the original PET, didn't have any sound built in. And then people started using the shift register of timer 2 on the VIA to produce sound. And people created adapters, and you plug them into user port, and that's how you got your sound. And that's how I'm doing it here, essentially, to get that original sound out. But so on later computers, Commodore standardized that, and they put a little piezo speaker in there, and that's your sound. Unfortunately, it's a really limited range. So I'm going to show you the range right now of that voice. So the lowest note you can really use is this one. And it goes as high as this. So that's all the bass you're going to get out of that voice. So. Yeah, there you go. It doesn't get useful above that note there. So that's kind of, you know, not really a great range. Now, I could, if I wanted to, write some routines that would quickly turn on and off some of those user port pins. And in fact, the best software I've seen that does this is Apple Crate for the Apple II, and it actually flicks the speaker bit on and off so quickly that it can actually do PCM sound. And so it uses pulse width modulation to flip that bit so quickly that you can get different volumes of sound, which means you can get like a 7 or 8-bit sound. And it's very much like the way that people used to play samples on the Commodore 64 by toggling a glitch on the volume controller of the SID chip. So that's really cool. I didn't want to do that again because somebody else has already done that. So I wanted to do something else. I wanted a better range, and I didn't want to just flick a bit on and off. I essentially want the Arduino controller to spend all its time worrying about MIDI. And I want the Commodore to spend all of its time playing effects. I don't want the Commodore actually making the sound. It's the VIA, like the SID in the Commodore 64. The VIA chip is the thing that makes the sound in the PET. And it does it without the processor doing anything other than saying, hey, play this note and start right now, or stop right now. But while that note is playing, the VIA chip does all the work. So I wanted a better range, and I wanted so much more than that. And so how do you find an extra voice in a machine that was never programmed with a SID chip? How do you do that without modifying the hardware and putting some extra chip on? That was my goal, and so I've reached that goal, and I'm going to show you right now what I've done. So, again, here, let me just turn off the effect there. So that's about the lowest note that you could play on the PET. And with my software, you can now go lower. So, now I can do bass lines with my Commodore PET. Pretty cool. But you know, I still wasn't satisfied. I wanted a little bit more. In fact, I'd like to do some stereo effects. So, how can you do stereo? Well, what you can do is have two voices, and that's exactly what I've done. I found a second oscillator in the PET, in the VIA chip, that literally every book says you cannot do anything useful with this thing, and I found a way to do something useful with it. So, I'm going to now show you what, whoa, that's not what I want to do, thank God. Okay, sorry, I almost did something very loud. So now, I'm going to play both voices at the same time, and you're going to hear the effect here. It's not quite as loud there. Now, unfortunately, the other voice doesn't go as low, so once you get into the bass part, it doesn't work so good, so well. So again, so, that is, oh, and wanted to do some, I didn't do any bass lines with the portamento, did I? Oh, wait, sorry, no, I wanted to do both voices with the portamento. There. So now we've got the full range, we've got a second voice, we've got stereo sound, and what was the other thing I was going to show you here? Oh yeah, and so the controllers also operate on that second voice, so you can do all kinds of crazy effects now. Oh, sorry, portamento off for that. There we go. And then the other thing you could do is, if you were to rapidly go up or down the whole scale, you can kind of get some other drum-like sounds if you were to program it in your synthesizer. So. That's a bad demo. Let me try this. So this could be like a bass note. Okay, maybe not. Yeah, anyway. So that's it. So you're wondering, how did I do it? Well, the VIA chip on the PET, on that timer, communicates with the IEEE bus. And so there's the VIA chip, and then there's another chip, and then it goes out to the port. So you can't access it out the back here. So what you have to do is tap right into the VIA chip. So if you clip onto the right leg on the VIA chip, you've got your second voice. You don't have to add any hardware. I'm actually building a little board that'll sit in between them so I can do, you know, a better job of outputting the sound and having them be the same volume and all that. But that is essentially it. So that's my demo, and that's my software, and I want to check the time because I do not want to go over. Okay, we're still good for time. So why don't I do this here? I will take the controller out and just kind of walk you through what I've done here. But again, like I said, I wanted anybody to be able to sort of download it. There is a MIDI board for the Arduino, so if you get the MIDI board and you get the Arduino and then you tap all the right pins, you can basically just wire the pins straight into the port. I mean, there's better ways of doing it to protect both sides of the whole thing, but it's really easy for anybody to download the code, buy a Leonardo, buy a MIDI adapter for it, stick it together, and literally just wire it directly into the user port, and you're rocking. So I will be releasing this as soon as it's ready. This little board here, all I have is a little thing you can set the MIDI channels. You can make it 0 for Omni, or, you know, right now I think this little thing, I took this off a DEC PDP system, but this will go up to 7 or something. I have this little connector here, and this is actually the output. And so what you can also do, and what I would like to do, is have the ability to use one keyboard and send wires to a Commodore PET and a VIC-20 and a Commodore 64, because they all have the same connector, they all have the same pinout for those pins, and that would allow me to stack up these 3 computers to make a really big, cool, fat sound. And again, it would be monophonic in doing that, but you wouldn't actually need 3 Leonardos. You can power them all pretty much straight up from the one board. So I think that's also kind of cool too. But so this is just a little prototype I made. That's about it. Oh, one more thing before I forget. In addition to finding one extra voice on the Commodore PET, I also went and thought, well, I mean, if I can find an extra voice on the PET, there's got to be more. So unfortunately, I don't have anything ready in a demo, but I found 2 more voices you can use on the VIC-20 and 2 more voices you can use on the Commodore 64. On the VIC-20, it's the same VIA chip, and both of those voices are accessible with the user port. And I have the pokes and a screenshot at home, so I'll upload those when I get home tonight, and you can try that out. But when I port this to the VIC-20, I'm going to use those extra voices, so you can have now 5 voices on the VIC-20 to make all kinds of cool sounds. And same thing with the Commodore 64, but it's the CIA instead of the VIA, the VIA. But it also has 2 timers. They're 2 16-bit timers, so you get the full range. And so instead of having your SID voices, you could have your SID voices and your 2 extra voices on the Commodore 64. And when I build an adapter, I was planning on having those go through the SID chips filter so that you can do that. So that's where I would like to take this. So that's it. It's all going to be, or already is, open source. And if anybody has any questions, you know, shoot. All right. Yeah, sure.
When you had the multi-voice, did you have them both playing the same pitch at the same time?
Yes.
And then are they just like a microsecond apart in timing? Or could it be like a little bit of a pitch difference?
So yeah. So the effect that you noticed was to do like a chorus type effect. If you detune one of the voices, it sounds kind of stereo and fuller. But because the original voice on the PET is only an 8-bit limited range voice, you can't get the tuning quite perfect. So I can't actually not have a little bit of that effect with both voices playing. And technically you need to write 2 bits to change the sound on the other timer 2 bytes instead of 1 byte. And so yes, there might be a few cycles difference there too.
Yeah,
as well.
I was just curious because it was just like a very, a small effect.
Yeah.
But I was wondering, was that a pitch difference or was that a timing?
So essentially in this case, there is probably,
Like phase.
that's probably what you're noticing, and it's probably the pitch difference. I don't think that there's a perceptible time difference. Like I said, you write to memory once to change the pitch on 1, you write to memory twice, 2 bytes. So there would be technically a timing difference as well, but it would be imperceivable. It would be very, very, a few clock cycles worth. So that's what you were hearing was the pitch difference. All right.
Now you know that the user port itself, you could toggle each of those 8 on and off and create 8 channels of
Yeah, no, absolutely, and that's a great point, and that's what I was talking about earlier when I said I could do things like that to make all these voices, but then the CPU is doing the work of making the sound, so I had the creative constraint of, hey, can I find another oscillator in this machine somewhere? So, but you're totally right, I could have 8 voices, and there's even a couple extra pins on there, and you can probably even do a couple pins on the tape port.
The only problem I found with the user port, it's a problem and it's a good thing depending on which way you look at it. It seems to latch. So if it latches, it means that you got to deliberately turn it off and deliberately turn it on.
Yeah.
Because it'll stay in whatever state it's in.
Right. Yes. I looked up some of the data sheets for the VIA chip, and there's a couple of glitches I've noticed. So there's a couple of points at which, when you go from certain notes to certain other notes, it's very hard to explain, but when I do the vibrato effect on certain notes that are on the border between an order of magnitude, it's hard to explain, but yes, there's totally some annoying bugs, and I'm still trying to figure out how to get around some of them, but because specifically you should be able to write to the VIA chip and turn it on or off, or change its pitch, and have that change be instantaneous. Unfortunately, it's not. Even though the specs say it should, it doesn't do that, and I can't figure out why.
There is some capacitance, and I think they call it slew time or something. The time it takes to actually to get to the state. Eh? So you have to, when you write the software, you have to take that into account.
Well, yeah, I hear what you're saying. That's a good point. But specifically, the documentation says that if you write the high bit first, it shouldn't change the pitch until you then write the low bit, byte. Sorry, not bit, byte. You write the high byte, you write the low byte. What I'm finding is I'm doing that, but it's changing it when I write the high byte. And then for 1 or 2 clock cycles, or however long it is, there's you can sort of hear it if you do certain things, and it's not supposed to do that. So I don't know if that's just a glitch in the chip. But the documentation says the VIA chip should work that way. It doesn't seem to work that way. So, but it's not a big deal. It's like I could show you, but I can do 99% of what it's a little crack, like not even a crack. It's like a little tiny little noise that you sometimes hear with certain effects at certain notes at certain times.
It's a feature.
So it could be a feature. Yeah, absolutely. So yeah. Anything else? Anybody?
Have you thought about recording, or do you just leave that to the MIDI side?
Recording the notes?
Recording the note sequence.
Yeah, so I right now it's just going MIDI out from the keyboard to the computer, so you could go into a DAW, like a digital workstation, record the MIDI and send it, and then record and play back. The software doesn't do any of that. I wasn't interested in doing that because I felt there's better ways to do that, and there's very little to be gained. I would think that something that would be maybe more interesting would be to do a drum machine and then have the trigger of the MIDI drive the drum machine, and then you could program patterns on the pad and have it be like a little beat machine. But yeah, I didn't think I could do it in a way that would be worth doing on the pad. Don't get me wrong, it's a great machine, but I think there's a lot more to doing it live and playing. And there's just, Pro Tools, Logic, Cubase. That problem's been solved. I was creatively looking for something that hadn't been done at all. Mm-hmm. And so this is sort of the path that I've gone down. But,
would it be possible to, as you were mentioning, lay down a rhythm or drum track and then put something on, and then you can then have it playing as a loop, and then you play on top?
Yeah. If you wanted to, you could program a little pattern, like drum machine recording thing, dedicate that to one voice, and then use the other voice as your MIDI input, and that would let you do that, and that would be some pretty interesting
I think that would be
chip
pretty
tune
cool.
sound.
You
Yeah.
have something to latch on to.
Yeah.
Because then you have that rhythm, so you don't have to make up the rhythm in your mind, you just follow it.
Right. Yeah. For sure. Very cool. All right.
Did you roll your own MIDI code for the Arduino, or did you use a pre-existing?
No, I rolled my own. I didn't. All the MIDI libraries required someone to download some files and copy them to a specific location, and then make sure that that works. And I wanted someone who is not a programmer or a hardware guy to go, okay, I can buy an Arduino, I can buy this adapter board, I can copy and paste the code and press one button, and it's working. So that was my goal. I wanted to be very accessible so that, people aren't dependent on me producing it and selling it and making PCB and doing all that. So, yeah. Anybody else?
One question on your hardware there. You're using a Leonardo board.
Yep.
But any of the Arduinos would do the same job, correct?
Yeah. I can't see. There'd be some pinout differences. I think the Leonardo has a slightly different pinout on this here, on this part. Is I think different. There's some subtle differences, but it's trivial. I specifically have it writing to one of the ports of the microcontroller, because when you write to a port, you can write a byte to a port and have it instantaneously change. But if you were to write to 7 individual bits, you would have 7 individual instructions, and for that, fraction of a microsecond or whatever it would be, you would hear different notes. And so I specifically grabbed some of the pins off this header so that I could have at least 7 bits from, I think it's port B or port C, or I can't remember, but it's some specific port. Not unlike the ports of the VIA where you have 8 bits. So, but yeah, it would work with any Arduino. Teensy is another good one. It's a little guy, and I might port it to that one too, because there's a lot of those, a lot of projects for that. And so, but yeah, it would be hard. So yeah, anybody else? Yeah.
You worked very hard to get the sound sounding right, but what did it sound when the sound wasn't right? How did you figure out what to do about it?
That's a good question. That's tough. I guess because I'm musical, I could hear when something wasn't working right. So if there was, for example, when I do the vibrato, I'm taking the pitch and I'm changing it ever so slightly up and down over a period of time. When you release the modulation effect, it sometimes settles on the wrong note. Instead of settling at the note, it'll settle on something above or below. And I can hear that, and it's a bug I haven't fixed yet. But, so I just follow my ears. So in terms of, debugging, I have these lights here so that I could work on the computer and work solely on this part of it without having to plug it into the PET. And then when it was mostly working, I plug it into the PET, change the software, debug that, and then they're working together. Okay, go to the next feature. And I can see in the lights, okay, if I'm doing the thing where I'm looking at the most recently note that you've played, and I'm rolling over to that, you can see if you know binary. And in fact, this isn't plugged in? Oh, I wasn't sure. But yeah, so you can see if it's doing the wrong thing or whatever. So that's part of the reason why I had the lights. But I actually have a little clip-on adapter that just puts the surface-mounted LEDs on there. So you don't have this, but I thought this would look cool for the demonstration. So that's why I did it. But yeah, I just follow my ears. Yeah. Anything else?
So going into the PET, you're just connecting to the user port plus this one connection to the other DIA, or?
Yes. So
You're not using a cassette port for anything?
No, I am using the user port for MIDI. The sound out, I just happened to solder a wire to the piezo speaker inside, but I could take it very easily from the user port.
CB2, isn't it?
Yeah, CB2, yeah. And then the chip, I wonder if I can, if anybody's interested, I can show you after. No, I've got the adapter board, so you can't really see it. But it's the 4th pin in on the VIA chip. So if you have a little clip, you can stick a little clip in, clip it on, and I'd put a little capacitor in there so you don't fry your chip when static discharge into your mixer, and plug it in your mixer, and there you go. So, and it's 5 volts logic, so it's actually a pretty hot signal when it gets in the mixer. It's pretty loud, and the nice thing about being only 0 or 5 volts is it's pretty quiet. But as we know with the SID, because it does different volumes and different filters and stuff, it's very hard to get a quiet signal engineering-wise. A lot of the 8-bit computers actually had problems with noise. The Apple IIgs had a really cool sound chip in it by the same guy, Bob, I forget how to pronounce his last name, but the SID chip designer went and designed a synthesizer chip that was used in the Apple IIgs. So the Apple IIgs and the Commodore 64 have sound chips by the same designer. And even though the chip's really great, there's the board is totally noisy when they engineer the board for the Apple IIgs. And so it's very hard to get a good, clean, quiet signal out of any computer, because computers are incredibly noisy inside. So that's definitely a big challenge. So it's nice, 0 or 5, so you're in or you're out, So yeah, any other questions? All right, cool. Thank you very much.